Now I will show you how to add 3 or more than 3 vectors. So for this we need to resolve each vector in x and in y component. So here I'm going to resolve the first vector a. Ax is the x component of this vector and ay is the y component. Similarly, for the second vector, bx is the x component and by is the y component. For this third vector, cx is the x component and cy is the y component. And the last one, dx is the x component and dy is the y component. So here I consider 3 vectors: vector a, vector b, vector c, vector d. And you can add more than these. You need to take one another vector, and the angle theta 1, theta 2, theta 3, theta 4 are the angle made with respect to x axis. So now I am going to write the different components. Like ax is simply, if a is the magnitude of vector a, then ax cos theta 1 is the x component. So y component is simply a sine theta 1. Similarly for bx and by, but here bx is vector b cos theta 2, b sine theta 2 is the y component. And similarly for x component of c, cos theta 3, and y component c sine theta 3. And you can do similar you can write similar component for the last one, dx and dy. So now we will add first 2 vectors. Suppose my new vector is x, and this is the sum of vector a and vector b. Now the component of x component of vector x is given by x component of a and x component of b. So this gives me a cos theta 1 plus b cos theta 2. And similarly, the y component of vector x is y component of a and y component of b, and this gives me a sine theta 1 plus b sine theta 2. So I added first 2 vectors a and b first, then I will add c, and then I will add d. Now the magnitude of vector x is simply square root of x squared plus xy square of square root. So you can plug these values and you can find out this is square root of a cos theta 1 plus b cos theta 2 squared plus a sine theta 1 plus b sine theta 2 square. So this square root is all over up to here. Now, okay, once I found the x components, I can find the angle. Suppose phi 1 is angle made by the x-axis with this made by this vector x with x-axis. So this is the vector and this is the phi 1. So this is vector obtained by two vectors, vector A and vector B. So last time we calculated what is this angle. So this angle is simply, you can write tan phi 1, this is equal to y component of A plus y component of B divided by x component of A plus x component of B. So you can calculate this phi 1 simply from tan inverse of this equation okay. So once you have your phi 1, you can do remaining calculation. Now we need to add a third vector. Now what we will do, this is vector x. Now we will again do the same thing for the x. We will find out the x component of x and the y component of x. In fact, we already have these components here, right here, the x components and the y components, or we can find from here too in terms of phi 1. If you already calculated the x component and y component, or if you already calculate the magnitude of x, you can do just x component is x cos phi 1, you can, or the y component is x cos, sorry, not a cos, it should be x phi 1. So you will again repeat the same thing. Now another vector will be the, or here I want to mention one thing, either you can use this one here or this one, or you can use those values. I mean, they are the same. For the x component you can use this whole value, for the y component of x you can use this whole value, or if you calculated phi you can use those values, it doesn't matter. So now let us another vector y, this be the vector of x plus the next vector is vector c. So this gives the vector c. Now we repeat the same process. Let's find out the x component. This is the x component of x vector plus x component of this vector is cx. Oh no, cx, yeah. So let me it's just x component is just c cos theta 1, theta 2, it's theta 3, maybe the x component, yeah, it's 3, and the y component of vector y is x sine, it's phi, oh, let me rewrite this one, phi 1 plus c sine theta 3. Now once you have x component and y component, then you can just yeah you can just find out the magnitude of this y vector denoted by y. This is x component squared plus y component square of square root. So you need to plug those values and calculate. And the angle, again same, let phi let's say it's denoted by another number, just j be the angle made by this vector y with respect to x-axis. Then this is given by the y component of this vector divided by the x component. So you can plug those values. I'm not plugging those values. You can plug those values and you can calculate j is simply tan inverse of y component divided by x component. So you again find this j. Now you added the three vectors. Similarly, you can do for the fourth one. For the fourth one, you can do simply let z be another vector that is given by vector y and vector t. So you have to do the same thing. G component of x is x component of this one plus x component of another vector. So y component of vector z is y component of vector y and y component of vector d. Once you calculate a vector, then magnitude of vector z is simply x component squared plus y component squared and square root. And suppose the angle be the gamma. Let's this g vector makes angle gamma. Let me write gamma like this. So now similarly tan gamma, this can be written as g component y component of vector z and x component, and you need to calculate this angle. This is tan inverse y component divided by x. So in this way you can find the sum of four vectors. So this is your sum of four vector, and this will give the gamma is the direction, and the gamma is the direction, and this z is the final sum. So you can similarly you can add more than four vector.